Hi all, welcome to another video, and in this video I'll be taking a shot at explaining what service mesh is once again. Now, before we get started, okay, first of all, now that I'm looking at the video that I'm recording, my God, you can really see the grays, huh? Like there's heaps of grays here, and because I'm sitting in the living room, there's a bit of echo, and also there's heaps of light coming in, so that's why you could the grays really show. So yeah, so it's a really sort of a cloudy and somewhat miserable day here in Sydney. Um, so it's well, I can't quite say that it's completely miserable because I mean, every once in a while, the sun comes out and then gives us a little peek, and it's nice and sunny, and then it goes back after like 15-20 minutes. It will go back and hide in the clouds. So for the most part, it's just cloudy, and it kind of makes me want to go to sleep or just sit on the couch here and watch TV. Um, yeah, so I mean, there isn't much to watch at this point because I just finished watching the latest episode of The Boys on Amazon Prime. It was alright. I mean, to be perfectly honest, for me, season three of The Boys with what's that guy called, Soldier Boy. That was that was the best. That was something else. I'm not sure if they can actually top that, but yeah, I'll keep watching it and to find out. All right, so let's start talking about service mesh. Now, the way I'm going to approach this is that I will I'll take a sort of a chronological approach. So I'll start talking about how we were doing things back in the day leading up to service mesh. So that's that's how I'm going to attempt explaining that in this video, and I'm hoping that it's better than my first attempt. Uh, yeah. So now, to know more about service mesh, it's important we understand a little bit of history. So, for those of you who've been in the industry long enough, you would know that back in the day, the way we were building apps, we were building what we call monolithic applications. So, monoliths are essentially, you've got the one application that's got all the business logic, and it's got all the code that does all the good stuff, all the backend code, and then you've got the front end code with the UI and all that, and then it's all um, hosted. It's all in just one application, right? I mean, sure, the UI code is decoupled from like the backend code, but at the end of the day, it's all in like this one application that we package and then we deploy, and then our users use it. So yeah, all of that was great, but then obviously, given the demand of how given the demand of um, products increased, and obviously the consumption of the all the online everything online increased. There was a need to sort of make it you need to meet the demands. Actually, you know what, I'm getting ahead of myself. Before that, so monolithic applications were great, and it all worked well, but obviously some of the challenges there were, you know um, this is what I can think. This is what I would think of. It was in terms of maintainability. So you've got a great team of engineers, and then they build this really awesome application, and they've done a great job maintaining it, and our users are using it and they like it, and so on and so forth. But obviously, they given the volatility of given the transient nature of employees, like nobody's really married to a job per se. Like, I mean, if you stay in your career like for 10, 20 years, that's terrific. But not everyone, you can't expect everyone to stay in the career that long. So obviously, the challenge here with this monolithic application was, maintenance, and then especially when it comes to large applications. So if you've got a new engineer coming in and working on it, um, so you're left with the task to teach this new engineer of how all the complex moving parts of the system work. Now, to solve that problem, um, what what we came up with was this thing called a modular monolith. So you've still got the one application that's running, that's doing all this good stuff. It's still the one application, but you have architected and carefully segregated various aspects of that application, and you've composed that into modules, right? And these modules can often be reusable. And what this means is, given that these modules are mostly independent of each other and they send each other messages, but given the self-contained nature of these modules, it's easier to get in on it and then learn it. And that was what we call the modular monolith. And obviously, still a lot of places still use that model, and it's actually pretty good. I mean, microservices are great if you need, if you've got a system with a very high demand. But anyway, again, I'm getting ahead of myself. So okay, we had the modular monolith and it was working great, but then, like I was mentioning before, like the demand for the products increased, and then there was, we needed to find a better way to make it more performant, to make our applications more performant, and to handle certain high traffic scenarios and to actually behave well. And by behave well, I mean like not crash or something like that, and to or not, or worse, like just have like take a really long time. The response time increase massively, and actually not sure if crashing is or taking a long time to respond is. I'm not sure which one is worse. They're both pretty worse. According to me, taking like longer response times are a bit. I'd say they're a bit worse. They would be a bit worse than the system crashing, because the system crashes. That's it. The users, well, they know it doesn't work. But if it takes a long time, you're just leaving the user hanging. Anyway, that's a separate conversation. So when the demand increased, we decided to separate out these functionalities into what we call microservices. So now think of this in terms of, say, the backend is like an API, right? And then you've got your backend, which is your API, and then instead of having just the one API that does everything, you've got multiple APIs that handle different aspects of the system. Now, it's so for example, something like say you've got an e-commerce website like Amazon or Flipkart or Alibaba or AliExpress or something like that. Now, so you've got if you've got a so when you've got a sale happening, right, and then there's obviously an increase in demand for people are browsing through the products. There's an increase in demand to fetch the products and to show, and even or things such as sorting the products by sorting the products by sorting the products by like the discounted the percentage discount, or by in ascending or descending order, or so on and so forth. So obviously, when these sort of things happen, it's like, in this way, what we can do with this scenario is that we can actually have separate services. So we've got a service that handles all of this stuff, like that just handles the product, that handles the fetching of the products and the search of the products, and so on and so forth. And then we've got a separate service that handles payments, or the checkout, or that that does the actual payment. We've got a separate microservice for that. So these are all still APIs. And in terms of the UI could be something that like it could be something that runs on its own. Like in my experience, what I have done is that I've actually built a React app and deployed that to AWS S3. So you've got Amazon AWS S3, and then you've got an option when you're creating an S3 bucket. You've got an option there that says host as static website. So yeah, you can do that. So that's a separate thing that communicates with your backend API. Now that's all good. Now, but see, when we are building all these backend services, the thing is, the services talk to each other. But see, at the end of the day, if we deploy a service on any public cloud, or if we deploy the service, it is potentially exposed to the internet. So then comes in the security risk. So the risk with the security of the website, like for example, what if it exposes certain data? What if someone gets into one of these API services or so on and so forth? That's an additional challenge that comes with having such a large microservice architecture, such a such a large number of microservices. Now, given the security issues and some of the uh, like for example, even other issues such as um, setting up monitoring and all of that with these sort of microservices. Um, Service mesh is an architectural pattern, if that's how you put it, and this is just to what it does is it abstracts service to service communication, internal service to service communication. So if the service needs to communicate with, if service A needs to communicate with service B, it would do so, and the outside world wouldn't really know about it. So the way it would typically, so the way service mesh works is that it would actually you'd have the service mesh architecture in service mesh, and then what sits in front of it, or what's the first point of contact of anyone from the outside world trying to get in, would be an API gateway, which would handle certain things such as like logging, monitoring, and like security and all of that. So for example, a client application, which is say the UI, it wants to get something from service A. It would first send that request to the API gateway. An example of an API gateway could be Kong or X-Ray, or those are the only ones that I've used. I'm sure if there's others, you can leave a comment in the video, and that'd be good. So it would send a request to API gateway, which will then figure out who this request needs to go to, and it will send it to that service accordingly. Because the API gateway also maintains a registry of the services within the service mesh. Now, obviously, with these services, are APIs, right? Now, the APIs is also this additional thing for you've got to do things like the monitoring and the error logging and setting up the alerts and so on and so forth. Now, for this one, each service has a sidecar proxy attached to it, which actually looks after all of this. So if service A wants to communicate with service B, it will actually go through the sidecar proxy, and the sidecar proxy the service-to-service communication is typically done using mutual TLS auth. So it's like MTLS. You know how that thing for exchanging certificates. So that's how it would be, and that's why service mesh that's the additional security that service mesh brings. Now this in itself is really, really complex, and to be perfectly honest, I mean, unless you've got a need for it, you don't really need to use this. I mean, this makes sense for like a very high traffic e-commerce website or any sort of banking application or something like that, because in most cases service mesh would be an overkill per se. It is good, it's great to know. I know about this simply because in one of my jobs I was working on I was working on building APIs with service mesh architecture, and obviously those APIs were built with the whole CQRS pattern. CQRS is a completely different thing. Again, it's for performance and all that. So I'll cover that in a different video. But in this video, I just want to touch on what the service mesh is, and well, this is my second attempt at trying to explain service mesh. I'll rewatch this video and then I'll make another one and try and summarize everything. Because I remember in this video, I realized that in this video, I spent the entire first 10 minutes talking about the history of web apps and stuff. So I'll try to make another video and make it a bit more efficient. I'll give it a shot. But thank you for watching this video, and until next time, I wish you well, live long and prosper.